So here we were yesterday. Pascal's law.
Yes, sir. Pascal's law I have stopped in middle, sir.
I will introduce it again. I will tell you what happened, why this law is required, why this law is required in the first place. What is the reason? I will tell you all the details. I will revise. It will be like brief review again. So I will do it again. This is water level. Why the water level is like this? Because water level will always be in apparent horizontal direction. This is apparent horizontal. Now, perpendicular to this will be apparent vertical. Perpendicular to this will be apparent vertical. Okay. And let us say I want to find out what is the what is the pressure at certain depth. Different colors better. Let us say these elements which I am drawing here. Let us say these are having shape of cuboidal shape. Imagine these are having cuboidal shape. At the end, it will not be cuboid, obviously. So, observe this small portion, this portion below. Observe it. This portion I'm talking about. This portion. This portion will have what shape?
Prism
This
shape.
portion will have shape of a prism
Yes, sir.
with right angle.
Triangular prism shapes.
Right angle triangular prism. This kind of prism means I am not drawing the three-dimensional diagram, but if I draw the three-dimensional diagram, then it will be this kind. So, but it is difficult to draw, so we understand it verbally only that this shape left here is this small shape is like prism. It is prism here. So, in this prism, I'm making the free body diagram of this that I made before only. So let me go to that again. This is the diagram I made last time. Let me make it again properly. So this is the diagram, and in this horizontal pressure is Px, vertical pressure is Py, and oblique side pressure is, let us say, P.
Peace.
And area, if this angle is theta, this total area is A, then I think you understand that this area will become
A cos theta and A sin theta.
this area will become A sin theta. Then what will be the corresponding forces? We know force is pressure times area. So I will take this pressure times area. I will take this pressure times area. This will become force now. Similarly here also pressure times area A. This is the force. What I want to do next, I want to balance the horizontal forces by balancing horizontal forces. If I balance the horizontal forces, then we get PA cos theta is equal to Px into A cos theta.
So P
Right.
equal to Px.
So P becomes equal to Px.
And then
Similarly,
vertically,
if I balance the vertical forces, I think I balanced somewhere. No, I did not balance.
no, you said us
Okay,
to do it,
I
sir.
said,
To
I
do
told,
it.
I think that you can balance those.
Yes, sir. We can balance it.
We can get P equal to Py, sir. Then
P is
PS
equal to
sin
Py.
theta
P is
equal
equal to
to
Py.
yes,
P
sir.
sin theta
equal
is
to
equal to
Py.
Py
PA sin theta is equal to
Equal to
P
Py sin
Py
A sin theta. A sin theta is
Py
sin theta.
A
sin theta,
theta.
sir. So we get
Right.
P equal to Py.
Means it is something like this. Those who are not understanding what I'm doing, here let me tell you, I'm doing it in this way. This is vertical line, and what angle this makes with vertical I want to find. So that angle I can find by this way. It is 90, and angle between two lines is equal to angle between their
Perpendiculars.
perpendiculars.
Yes.
So if I draw a horizontal line, this horizontal is perpendicular to the vertical line here, 90 degree, and this is also 90. And angle between line 1 and line 2 is theta. So angle between their perpendicular to line 1 and perpendicular to line 2, that will also be theta here, theta. So this will become 90 minus theta. Then vertical component will become PA sin theta.
Yes.
Therefore, I'm writing by balancing vertical forces.
P is equal to Py.
Yes, we are getting P is equal to Py.
Py.
It means pressure is independent of direction. In all directions, the pressure is same. So if I take at a point, why I'm calling it as a point? Because I told you that this is very small. Rm tends to 0. So therefore, I should just treat it as like a point. It is not a big prism. It is almost like a point for me. So at any point inside the liquid, pressure from all sides will be always equal. This is the proof. It is very good for us if I know pressure at all directions is equal. Therefore, I can say that here, if pressure is here P naught, and I told you one more thing yesterday, that in case of air, the pressure remains same. It does not vary with depth that much significantly. It changes with depth, I know that, but it changes little over larger depths, not over small depths of containers. So if here it is P naught, here also approximately it is P naught only.
P naught. Yes, sir.
But this horizontal length is X, and the vertical length you can assume to be Y. So I can just say it is Y and it is X. Then here in this triangular prism part here also it will be like a prism shape here. Yeah, this place. It is also prism, and here also it will be small prism. But as you know that pressure in the prism will be same from all sides. So in this prism also, if here it is P naught, here also P naught, here also P naught, same pressure only. So we don't have to worry. We can just apply the force easily here directly in this side. That will become something P naught into whatever the area for this is. Let us say dA. That is a force. And what force from this side? From this side, some other force P into dA from left hand side. So, and pseudo force, because acceleration will be in the right side, then only pseudo force will be back side. Why I assumed acceleration to be right side? Because I know the apparent vertical direction is this. All mg direction is downwards. Then pseudo force direction must be this. Then only the resultant direction will become this apparent vertical direction, mg dash. Therefore, I understood that pseudo force is backwards. If pseudo force has to be backwards, then acceleration should be forward. And it is, I think, common sense observation. If you are really having some container and you start suddenly pushing it forward, then you know that water will start going backwards, right or not?
Yes, sir.
Yes, sir.
So because of some inertia, water will tend to remain at rest. It will tend to remain backwards, but the container is pushing it forward. So it will change its surface shape, and that shape will not remain
The water spills out
horizontal,
backward.
but it will become inclined. It will not remain horizontal. What is my aim? What I want to determine here? First of all, my aim is not to determine anything that much. As much I want to just tell you the basic laws, like pressure in all directions is same. One law. Second, that the in air, in atmosphere, the pressure changes with depth, but not significantly. So I assume here also P naught, and here below also P naught. That is another thing I wanted to say. You can keep on noting these points somewhere. Okay. And third thing here I will mention now, that is we want to find out what is the angle of inclination of this um, surface. If A is given to us, assume given A, and I want to answer in terms of A, what is this angle theta? So I'm giving a method to do that. What is the method? Method will be this. I will write the question for this in horizontal direction. I will be getting in the direction of gravity, or in the direction of apparent gravity, the pressure increases. If here it is P naught, sorry, if here it is P naught, what will be y depth below? I think you know already. Y depth below will
Not
be
plus
P
rho
naught
G
Y.
P naught
P naught
plus
plus
G
Y.
into
Rho G Y.
EH.
Similarly, it is also another kind of depth. We can say it is depth according to the pseudo force. So I can say here it will become P naught plus MA into P naught plus MA into X. Sorry, sorry.
Rho A into X.
Rho A.
Rho A into X.
Rho A into
Rho
X.
A into X.
Rho A into X, sir.
Yes, sir.
Then what we get finally? Then by this we are
AX
able to
equals
get
to
some
rho.
relation. I think
Gy equals to Ax.
Gy
Yes, sir.
is
Gy
equal to Ax, but I
AX
know that y upon x is tan theta.
tan theta.
Tan theta is equal to A by G. So what is acceleration coming out to be?
G tan theta.
You know why by x is tan theta? Reason is, see this triangle, right angled
Opposite
triangle.
by.
This
Yes,
theta
sir.
perpendicular divided by. But okay, I because it is really very important topic which we are discussing now. So I want to do it in many ways, not in one way. I'm not satisfied again. I want to do it another way also. So what I want to do now, I want to write the equation properly, analyzing this this part. I want to analyze properly. Let me copy it to other place. I want to make its free body diagram separately. So from one side, pressure forces P naught into dA. The force from the left hand side is P into dA. Pseudo force is M into A. So my equation is P into dA is equal to P naught into dA plus M into acceleration. Then I will divide by volume. If I divide by volume, then I will be getting P upon volume means X into dA is equal to P naught into dA upon X into dA plus M into A upon X into dA. But I know mass upon volume is, I could write it as dm also. I could say it is dm.
Sir, first
Mass upon
step.
Sir,
volume
upon
is,
the first step, P into D
P
also
into
there,
DA.
sir.
first step is P into dA is also there. Sorry.
DA.
Yes,
Yes, sir.
Then dA cancels. We are left with
P by
P
X.
upon
P by X equals to P naught by X.
upon X
P naught by
plus
X.
rho into A.
D. Yes, sir. Rho
Yes.
AX. Yes, sir.
That only we wrote there. So if you are not, because I wrote directly this, so I thought you need little more explanation. Some students may need more explanation. So yes, but it should be very much clear, means 100% clarity. Okay, it should be 100% clear to you. So from here we are getting this thing finally. Okay. Similarly, other side also we are getting, means it is sorry. Although from here I am getting, I hope you understood it now, right?
Sir, yesterday you told this.
You understood it properly?
Sir.
Good.
Sir.
So then similarly for vertical, that I'm not even making. But again, I will really not end it here also. I want to really analyze it much more deeply. Okay, let me tell you one more thing here. That will be interesting for you to, an interesting expression I will give you. Very interesting expression. If I have any, if I have any closed container or any open container also, doesn't matter for that purpose. if I have any container in which we have some liquid, okay, whether it is now moving or not moving, whatever is the situation, one thing I can guarantee, that around a closed loop, do you know that the formula for was dp by, what was the formula for dp? We have derived some formula yesterday.
dp by dy is equals to rho into g
dp by dy
is equals to rho into g.
I wanted to write in terms of derivative also. You remember? Yes, this one also is there. dp by dy is equal to g. That is one thing.
Yes.
And p is equals
I
to
think I
rho
did
into
okay.
g bar dot
I got the
br
point.
bar.
Yesterday I did not explain that much. Today I will explain it more. What is dp? dp is equal to rho into e. It is e dot dr. You know that, which I can write as rho into
Yes, sir.
ex plus ey
Plus EY into DY plus DZ into
plus ez into dz. That is equal to dp.
dz.
Then I can write del p by del x equal to ex. 1 upon rho also, rho into ex. Del p by del y is equal
You
to.
told yesterday, sir.
I told already.
That's it.
Sir, you said, sir.
Then I can write it del p. This I have not written anything. Del p I can write finally. Del p, del vector operator del p, that will change
Rho
the
into
pressure
EX
scalar.
plus
That will change the scalar into vector by saying rho taken common into
EX plus
e
EY.
vector.
Yes, sir.
It will become rho into e vector. Okay. Del p by del x I cap, and this is along j cap, and similarly del p by del z along k cap is equal to rho into ez. So if I add all the x, y, and dz values, then we'll be getting net value of e. And what is del vector? Del vector, as you already know, some of you know, I think so already. Del by del x I cap plus del by del y j cap plus del by del k cap. It is just a vector operator. It is just a vector operator, and on its own it does not mean anything. But when it gets multiplied to pressure, then it means something significant. Then it means rho into E, the field. One more thing I would like to add here now. This is one way of writing. In integral form also I can write it. I have written last time also in integral form. What I wrote there? I wrote
Sir, once go to back page, sir.
yes. Done.
Diagram. Sir.
Then, sir.
Diagram means, okay, this diagram is not explained yet. Let me explain you this diagram also. In this diagram, let us say some liquid is here in any container, and we are moving along this loop. I can say this thing. Do you remember that E dot dr around a closed, E dot dl also sometimes I think we call it, around a closed loop is equal to 0. I have told you or not? For conservative fields or forces. For conservative fields, the actually it is not this, it is force F dot dr around closed loop will be 0. If it is for force, then force upon mass will be giving us field. So for field also it will be valid. Okay. So for conservative fields, the line integral around a closed loop, we call it as line integral around a closed loop. Line integral around a closed loop is equal to 0. For what kinds of fields? For conservative fields. For conservative fields, this will always be happening. Then I can say similarly, because rho into E gives me, what does rho into E gives me?
0.
Rho into E dot dr. If I multiply by rho into D into dot dr, that is also 0, because rho multiply rho, nothing happens. It also changes to 0 only. But this will be del dp also, because dp is equal to rho into E into dr. See here. Then dp in a closed loop will be 0. Means the sum of pressure differences around a closed loop is equal to 0. Sum of pressure differences around a closed loop will be always 0. It is like KVL. Some of you may know Kirchhoff's voltage law. If you don't know, then no need to worry. We will study about it in 12th class. But if you have studied a little bit, then you may remember somewhat that sum of potential differences around a closed loop is 0 in a circuit.
Yes, sir.
In a circuit.
Equal to
Loop, junction loss.
KVL. Yes, you know that, right? Sum of potential
Yes, sir.
differences around a closed loop is 0. Same way here. Here it is not potential difference, but it is pressure difference. Sum of pressure differences around a closed loop, any closed loop within the liquid. Any closed loop you take within the liquid, you cannot go from liquid to solid. You have to stay within the liquid. And for all the closed loops, it will always be valid. Sum of pressure differences around a closed loop will always be equal to just 0. Understood? What does it mean?
Yes, sir.
Sum will be 0. It means if, let us say, I go from A to B, then pressure increases. And then when I come back from B to A again, pressure decreases. So if increase is taken positive, then decrease has to be taken negative. Then
Negative.
sum total will become 0.
0.
Means the amount of increase of pressure will be equal to amount of decrease in pressure, and overall pressure change will be 0 in any closed loop within the fluid. It is any closed loop within the fluid. Within fluid. Is it okay?
Yes, sir.
Yes, sir.
Right. So let us use this again back to our same problem, original problem only.
Sir, you told that on all sides pressure will be same, no, sir, for a body.
Where?
For a body on all sides pressure will be
Yes,
constant.
yes, I told it.
So that only for accelerating.
No. What are you saying? Not like that. Oh my God. It has nothing to do with acceleration. Where did I use acceleration here? Tell me.
Means the body was moving.
Where is acceleration being used in this diagram? I started from one example, and I said that in that example, which was that example here, I wanted to teach you the free body diagram yesterday. That was my main purpose. So while I was teaching with the free body diagram, some of you may be confused. Some of you were confused by this thing. You may were thinking that, sir, why are you not taking this pressure here, P naught into A? And that was correct. Then I proved that if this pressure is P naught, if I take it like this also, then this pressure also will be
P naught only, sir.
P naught.
P naught.
That was the whole purpose of this. Okay.
Okay, sir.
But I'm happy about one thing, that this thing I wanted to tell myself, but some of you raised this doubt yourself only. It means you are having that deep understanding that you are able to derive the Pascal's law. It is like derivation of Pascal's law. You went through that. Means if I would have probably given you some time to think over it, then probably you may have also concluded this Pascal's law yourself. So it is really wonderful and it is nice, because Pascal's law is a very famous law, and a scientist has given this, and you were able to derive it yourself only by understanding how to make the free body diagram. So it is nice to see, and you should remember it, that yes, the pressure in all directions will be same. If I'm at a given point. Now I cannot take a big, although in NCERT, unfortunately, they have given a wrong diagram for this. In NCERT, if you see, they are making such a big prism diagram there, and in that they are proving it. That is very bad, because it is valid only for small, at a point pressure in all directions will be same. I cannot guarantee if it is a big diagram, then here and here also pressure will change. From top to bottom pressure will change. How can the pressure be same in all places? It will not be same in that case. So that diagram is wrong. Okay. But law is valid. Law is valid, but the diagram given there is wrong. Pascal's law, I think it has another statement also. This is one statement of Pascal's law. There is another also. I don't know why they state it in two different ways, or maybe it is like Pascal law 1 or 2. I really don't know much history about why they are stating in another way. But there is another way of statement of Pascal's law. That way I will explain it. They say something like this also, that if I have a closed container with maybe some pistons from which I can increase the pressure. Let's say this is a situation. In this closed container, there is a fluid. From here, if I apply the force.
Sir, once say definition of Pascal's law.
Definition is this, what I explained before. Pressure in all directions is same. Another, I'm defining now another way. There are two statements given. I don't know why those two statements are given. I don't know whether why they give those two statements. But another statement is this: when we apply force in a container at any one place, by which it is a closed container containing fluid, if I am applying F force in one place, then F upon A will be the, here it has area A. What will be the pressure increase in this space? In this space means in, okay, let me name some points. What is the pressure increase at point A? You know that because at A we are applying extra force F by A, then extra pressure will be now. Already what pressure was there? If it is open to atmosphere, then the pressure was already P
P
naught.
naught, sir.
But
P
when
naught,
we
sir.
applied extra,
P naught plus
P naught plus P.
P naught plus F by A or P naught plus P, because P is F by A, correct? But,
Yes, sir.
or let us call it delta P, change in pressure, extra pressure. But if I ask you this thing, what is the excess pressure in B? Or what is the excess pressure in C? Or what is the excess pressure in D? Or what is the excess pressure in E? Then what will be your answer? At all points, the pressure increases by same amount in the closed container. In the closed container, if we increase the pressure at one point, then at all points, the pressure will be increased by the same amount. So originally, let us say at pressure at B was originally PB. What will be the new pressure at PB? That will become PB plus delta P. What will be new pressure at PD? At D point, PD plus delta P again. At C point, again same thing, plus delta P. Means at all the points, pressure will increase by same amount if we apply force at any one place. Understood?
Sir, I
That
had
is
a
another.
doubt, sir.
Yes.
Sir, in HCR, they given a like a U-shaped container. If we keep a pressure in one side, then there will be pressure in opposite side.
Right.
Means in that container, all sides same pressure will apply, sir.
Yes. Pressure will be increased by same amount everywhere. That is what I'm also saying. Pressure increase will be same amount everywhere. It will be same amount everywhere. This diagram is given in different ways. Let me give in another way. This way also will find this diagram in books. There is one opening here, one opening here. This is liquid here, and here there is a piston. Liquid here, here also there is a piston. Let us say I apply force F here also, and I apply force F here also. And this is let's say gravity free space. We are applying F force in all the places. I'm not saying that from A to B because of gravity the pressure is more. Not like that. Assume that from A to B the pressure is in the beginning it was something same already, or zero pressure or whatever it was. It was, let us say, initially P naught. Let us say it is P naught here. Originally it is P naught here also, and it is P naught here also. Or we can think that A, B, C, D, E all are in horizontal plane. We are looking from the top view. So if we are looking from the top view, then all these will be at same pressure, all sides, originally. But when you apply extra force F, what will be the new pressure at A point now? What will be new pressure at A? What will be new pressure at B? Tell me. Let us say PA dash, PB dash. After applying force in this place, in the second place, in the third place, what it will become now? Originally it was PA. What it will be now?
Three
plus
F by
by
S,
S,
sir.
sir.
That is common misunderstanding. It is not 3F by A. It is F by A.
They will cancel.
Yes, sir.
It is
Will
F by
get
A.
cancelled, sir.
Here also PB plus F by A. What is happening here actually? What was the main point here? Why they make such diagram? Why they give the three forces here when we need only one force to increase the pressure? Their aim is not to increase the pressure here only. Their aim is to check that on increasing F pressure here, on applying F pressure here, F force here, what force we need to apply this side? What force we need to apply this side to stop it? Let us say a person A is standing here and he is pushing it. Another person B is standing here to check, and another person C is standing here to check that what force this person is applying in this place. So if these areas are same, then if this person starts applying F force here, then to stop the water from coming out, to stop the water from also have to apply same amount of force. Otherwise, because the pressure will be increased by same amount in all the places. If pressure is increased by same amount in all the places, then everywhere the force will become same P into area. Extra force will become P into area. Then this person also should apply same force to prevent the water from coming out. Otherwise, this piston will start moving in and this water will start flowing out. If we don't want it to flow out, if we want to keep it in equilibrium, then this person should also apply the force which is equal to increase in pressure from inside. So this force, this he should apply the same force per unit area which is equal to increase in pressure from inside. That much he also should apply. That much he also should apply. Okay. So everywhere the pressure increase will be same. If it is area, if this area is 2A, and if this area is 3A, then because pressure increase is by same amount, this area at the top area was A. This area is A, this area 2A, and this area 3A. Then
This side
this
here
person should apply force
2F and
F2.
this side here 3F.
This person should apply force F3. What F2 should apply in order to stop the water from flowing out? Then extra
Like
force
this.
F2 applied should become equal to pressure, extra pressure multiplied by the area. What is the area in two side? In second side, the area is 2A. Then P is what was
P
P?
is
P
equal
was
to
F by A.
FPS.
F by A into 2A. Then what force
2F.
this person should apply now? 2F
2 times up.
to stop the water from flowing out. Similarly, what force the third person should
3
apply
Fs.
now? Then yes, 3F. Understood?
Yes, sir.
Right.
That means from all sides equal pressure they should apply, sir, to stop.
2F. 3Fs.
Stop.
Mainly, we can say that the pressure increases in the container by same amount. If we increase the pressure in one place and it is a closed container, then pressure is increased in all places by the same amount.
Okay, sir.
If we increase in pressure in a closed container at any one point, then at all the points, the pressure, the increase in pressure is transferred undiminished without decreasing. The increase in pressure is transferred undiminished to all the points inside the container. Okay, we can write this way. What?
Explain this problem again.
Here, see, it is not even a problem. It is just simple thing only. When we increase the pressure in one place, then pressure will be increased in all places. That's it. When we increase the pressure in one place, pressure will be increased in all places by the same amount. Nothing else, nothing less, nothing more. Just that only. Just listen what I am saying. When we increase the pressure in one place, it will be increased in all the places by the same amount. Okay. That's it. Nothing less, nothing more.
Direction,
What? Whether you apply fourth direction also, everywhere the pressure is increased by the same amount. In this, where you are not, where this piston is also not there, in walls also the pressure is increased by the same amount. But that's because the walls cannot move. The walls are themselves applying the walls are not just moving, but means the walls are also applying the same pressure back on the liquid. But here this is a piston which can move. If I don't want it to move, then I should apply the same force inwards in order to stop it moving from outwards. So if inside the pressure is P, then outside also I should apply the same pressure inside,
Pressure applies
so that
P.
these are
P,
balanced.
sir.
Understood?
Yes, sir.
Right. So
Sir, for small areas there will be more pressure, or sir, for large areas more pressure as well.
no, nothing like that. It depends on the force is same or not same. It depends on that.
Does not
If I
depend
say
on
force
areas.
upon area is pressure, if I say force upon area is pressure, but it depends on what force I'm applying. If force applied is equal, then yes, then pressure is inversely proportional to area. But first, this thing should be there that force applied must be equal. How can I directly guarantee without saying force applied is equal? How can I guarantee that for larger area, large pressure or what? In the liquid, the pressure is same in the horizontal plane. In the same horizontal level, the pressure is same in all the places in the liquid.
Okay, sir.
Okay.
Sir, in big volume container volume, less, more.
I'm not able to hear what you are saying. In the container volume, what does it mean?
Means pressure varies with volume, sir.
In a container, the pressure varies with volume. No, what does it even mean? I don't understand that. Why does the pressure vary with volume? What do you mean by saying that? I don't understand that.
How does it related, sir?
What is
Big
related?
volume container you were saying, sir.
What is related to what? I don't understand. Volume is not related to pressure. I don't know what you are even saying. I don't understand. how we got the pressure, how we derived the pressure, how did we derive the formula P is equal to P naught plus rho g h? Are you remembering anything? If you remember, then what volume has to do in this? I don't understand. It increases with depth. If depth is y, then it will become P naught plus rho g y. What volume has to do in this? Less volume or more volume doesn't matter. I don't know what you are even talking about. Less volume or more volume doesn't even matter. It depends on the depth from the surface.
Okay, sir.
If we are at same depth from the surface, here y deep, and here also y deep, then pressure will be same in both places. Oh. If here also y depth, here also y depth, then pressure will be P naught plus rho g y. Here also P naught plus rho g y. Okay. If I have a tube pipe, or a tube in which the water is filled up, it is a stationary tube. If here it is filled up to certain level, then the other side also the level will be same. Level cannot be different. For the fluid at rest, other side also level will be same. If the container is not accelerating, if it is accelerating, then level will be equivalent to the apparent horizontal level. Let us say it is accelerating, then pseudo force will be backwards. Pseudo force backwards, mg downwards, then the apparent gravity this side, and this will be 90 degrees. Then this will be new red line will be apparent horizontal line. This will be apparent horizontal. Then level will come up to this place only. So what will be the level? Level will be always in horizontal or apparent horizontal direction. There will be the water level. If it is same liquid, now if it is one side and different liquid, other side different liquid, then it is a different scenario. If it is same liquid in the container, then it will be they will be occupying same level. We can prove it although. We can prove also. I am asking you one thing to prove. From that, there you can get the answer. Let us say their levels are not same. Let us say this level is H1 and this level is H2. Then what I am getting here? I know pressure at the bottom from starting from here. If I calculate, then it will become P naught plus rho g into H1. But if I calculate from this side, then it will become P naught plus rho g into H2. And we know pressure from left side and pressure from right side will be equal at the same point. These two will be equal. So what we are getting from there? H1 is equal to H2. Understood?
Okay, sir.
So at the same, therefore these levels H1 and H2 heights will be same. These cannot be different. If it is same liquid. If it is different liquid, rho 1 one side, rho 2 another side, then formula will become rho 1 H1 is equal to rho 2 H2. Okay.
Yes.
Any confusion in
Yes, sir.
Yes, sir.
any confusion in
No
using this
confusion.
No
formula?
confusion, sir.
Still, for further clarity, I would like to add, even if you are seeing no confusion, I would like to add here. How are we getting this? Because if you remember, we derived it for which kind of container we have derived it. We have derived for such a container, which is just containing liquid which is means cylindrical container, but not such tube. How do you know that for tube also it will be valid? We did not derive it for the tube. Maybe somebody may think like this, that if it is a tube like this, and in this is filled with water, someone may think in this way that here pressure is P naught, then at a it is the length L. You may think like this also, P is equal to P naught plus rho GL. Is that right? Not right. Why is it
L
not right?
cos theta.
The reason is this: dp is equal to rho into G dot
L cos
dl
theta,
integral.
sir.
L cos theta, sir.
L cos theta, sir.
P naught to P, then it will become P minus P naught is equal to, start from this formula. I want you to be comfortable with this. Rho into G. G is downwards. This angle is theta. This is, you are saying wrong. 90 minus theta. So G dot dl will become G into L cos 90 minus theta, which will be sin theta.
Okay, L sin theta, yes, sir.
then I'm getting rho into, g into dl sine theta, which will finally become rho into g into sine theta taken out, and dl integration will be L. That is P minus P naught. So what we are getting P as? P is equal to P naught plus rho into G into sine theta into L. And L sine theta is the vertical height. So I could have just written it as, P naught plus rho G H. Okay. I hope it is clear now, 100%.
Yes, sir. Clear.
Next, we have,
Sir, wait, sir, please. Okay, sir.
now I'm asking you, what is the pressure at the bottom of the tube? I'm giving you this tube here. You answer, what is the pressure? This tube is open to atmosphere. And acceleration this side is A. This angle is theta. Down, it is accelerating. The tube is accelerating. Find out what is the pressure at the bottom of the tube if the water is filled up to length L. Now you find out what is the pressure at the bottom of the tube. Yes. Say something.
Maybe P naught.
Water will move upwards, backwards, no, sir.
It means you are not able to apply the formula and you are thinking that you are understanding, but you are not understanding anything.
I think P equals to P naught plus, sir.
Mm-hmm.
Hello, sir.
Yes, say.
P equal to P naught plus rho into A resultant into H, sir.
No. What is H? Doesn't even matter. If you are giving me answer in terms of something which I don't know, that is wrong.
Sir, P is equals to rho
P
plus
naught plus rho G into L sin theta. Axel.
Completely wrong, you're saying.
P naught, sir.
P is equals to rho into A by tan theta into H.
Sir, I mean P equal to P naught plus rho into A resultant into L sin theta, sir.
No, wrong.
P naught only.
P plus rho else.
Wrong. Everybody is saying wrong only, and you are saying that you are understanding. It is equal to rho into G dash effective rho into Let us say A is along. This is x-axis. Let us say this is y-axis. Downwards is y-axis. So what is G effective? G effective is becoming AI cap plus GJ cap.
AI cap plus GJ cap, yes, sir.
Minus
Dot dot
No,
dr
sir,
is
plus
dxi cap.
only.
What is it? Rho into A into dx plus rho into G into dy. What is P equal to? P naught plus rho AX plus rho G total y. What is total x from here to here? What is total y from here to here?
That is L
L
cos
sin
theta,
theta,
sir.
L
X
cos
is L
theta.
cos theta. Y is L sin theta.
That is answer.
Okay, sir. There we didn't take dr bars.
Those who are saying something wrong, you are saying something like P naught plus rho into G or dash into L. That is completely wrong. Somebody was saying rho this into L sin theta. G dash is in which direction? That is in some other direction. I don't even know what is the direction of G dash. Then how can you say the component of G dash with L that you are taking sin theta? How are you getting sin theta here? I don't understand. It will be G dash dot. Okay, I can say this way. I can say it will be rho into G dash dot L dot L. But what is that dot product? It is not sin theta. Sin theta is different angle here. How are you
Yes,
getting it
sir.
as sin theta there? I don't understand. It is G dash into L into cos alpha, where alpha also is unknown. I cannot do therefore in that terms. This will be the answer. Mainly focus on this part. This is simple part without any much complicated thing. This directly we could have understood. Although this container, this is a tube, and it is not even a full container. But I can imagine that if it is a full container, then I will see how much deep we are going and how much horizontally we are going. In depth pressure increases because of G, and in horizontal the pressure increases because of A. Think like that.
Yes, sir.
Yes, sir. Understood.
Okay. Right. How to do? We can do it by
Balancing pressures.
by balancing pressures in which
Yes,
place?
sir.
Balancing pressure in any one place. I can take this place.
Joining. Yes.
At the interface, I can take. What is the pressure in this place? Here pressure is P naught. Here it is P naught. Then at the interface, the pressure will be
rho plus
rho 1 into G into
3.
this is equal to.
Yes.
Now take due to the other liquid.
P naught plus
Balance the
rho
pressure at the
2
interface. Plus rho 2 into G into H.
rho 2 into GH. Yes, sir. Right.
Here pressure is
Rho
P.
1 by rho 2.
Then we are getting P naught, P naught cancelled.
Rho 1 by rho 2, 1 by 3.
H is equal to rho 2 into G into H. 3 into rho 1 is equal to That is the answer.
Yes, sir.
Okay. Now do one thing. Find out the ratio again. If
Sir.
Sir,
Sir.
so, I am saying that there are two arrangements here. Case 1 when acceleration 0. Case 2 when acceleration is g by 2. Now you do the same question for case 2 when it has acceleration g by 2. Yes, do for that case.
Sir, rho 1 by rho 2, 5 by 6, sir.
Rho 1 by rho 2 is
5 by 6.
I don't know. Let me find it out. P1 I know will be equal to, what will be P1? P0 plus rho into, downside, there is no role of pseudo force because pseudo force is acting in horizontal direction. Downside, it will be just rho into g into h plus y. That is P1 pressure. Correct or not? H and y,
yes, sir,
h plus y
correct, sir.
total. So
H
P0
plus Y
plus
dot.
rho into g in rho 2. P0 plus rho 2 into g into h plus y. That is the pressure of P1. But what is pressure of P2? That is more than P1. Why more than P1? Because pseudo force on this liquid is acting backwards. Acceleration is to the right. So pseudo force is towards the left. this side. So from here to here, we are going in the direction of gravity. Here to here, we are going in the direction of pseudo force. Here to here, we are going opposite to the direction of pseudo force. So, sorry, opposite to the direction of gravity.
Gravity,
So
yes.
here it will decrease. Whatever increases this side, same it will decrease this side. Okay. Let us write the complete equation for pressure P only, starting from right hand side first. That will become, again P will become P naught plus rho 2 into G, rho 2 into G into what? Into H plus Y plus rho 2 into A, rho 2 into A into what? Into 3H, rho 2 into A into 3H plus rho 2 into A into 3H minus, now why minus? Because it is decreasing as we are going against the gravity, G into rho 2 into G into this Y, that is it, that is P. Now start from the other side. This was from the left hand side, this way. Now go from here to here. From here to here, simple. Just rho 1 into G into G into 3H. Acceleration is
J by 2, sir.
G by 2.
G by
J by 2, sir.
It is 5 by 6, sir.
correct. It is 5 by 6. That only you said, I think, before. Huh?
Yes, sir.
That is correct only. Correct. Another question of YouTube.
Sir, in above one doubt, sir. Sir, P1 can be find from P0.
Yes, always we can do that. Although why can't we do that? Start from P0. Start from here. What is the pressure increase? See, actually we are writing, it is like KVL equation. In KVL we are writing the whole loop equation actually. Sum of pressure differences in a closed loop will be 0 as long as we are staying within the fluid. This is liquid fluid, air also fluid, so we are in the fluid only. So start writing from any one place to another place. Let us say from A to, let me name these, name these, and I will go according to that loop. A, B, C, D, A, B, C, D, E, and back to A, A, B, C, D, A. So I can write this equation. In loop A, B, C, D, A, sigma delta P, sum of pressure around a closed loop will be what? That will be equal to 0. Let us write that equation. So as we are going from A to B, then pressure is increasing or decreasing? How to tell increasing or decreasing? We are going in the direction of gravity. In the direction of gravity or pseudo force,
Pressure will be decreased.
Pressure increases. In the direction
Pressure
of gravity,
increase.
pressure increases. So what it becomes here? How much is the increase? How much
Rho
is the
1 into
increase?
3H.
Rho into
G into
rho 1
3H.
into G into 3H.
G
Increase
into
plus.
3H.
Then again increases. How much increases now? It is rho 2
Rho
plus
2
rho 2
into
G into Y.
G into
Y.
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 Then we are going against pseudo force. Against means decreases.
Minus
Minus
rho
rho 2 into
Rho 2
A
into
into
A into
3H, sir.
3H.
3H.
Then we are going against again. against gravity again.
Minus rho
Minus
2
rho 2
into
into
G into H plus
G
Y.
into
G
Y.
into H plus Y.
H plus
And we are
Y.
reaching at E. We are reaching at E, but E to A, there is no pressure difference because it is air. And in
Atmospheric
air,
pressure.
we assume the pressure difference in air to be 0. Plus 0 is equal to 0. Let us write the question of what do we get then? We are getting y cancelled. Y term gets cancelled. Rho, this term gets cancelled with Y. Then we are left with again same equation only, I think.
Same, sir.
It will be same equation only. So we are writing this sum of pressure differences. Sum of pressure differences in a closed loop is equal to 0. We are writing this equation. Okay. I hope it is understood now.
Yes, sir.
Yes, sir.
Yes, sir,
Let's go
understood,
back
sir.
for ratio case 2 also, sir.
This is case 2 only. Oh my god, what this boy is understanding really. This is
Not
case
to,
2 only.
I told to take screenshots, sir.
Okay.
Okay, sir. Thank you.
Next. Let me draw a few YouTubes and I will make those standard and then I will ask questions based on those. Okay. And then mhm. This is liquid filled in the YouTube and we are pouring another liquid in that. This liquid filled container we want to pour into this. So the density of this one is given as rho and this density is given as 2 rho. Question is, how much high will it rise after we pour this liquid into this length? What is length given? This length is given as 5 centimeters. How high the liquid will rise? What is the height raised by the liquid on the other side? Obviously, it will raise height or not as we start pouring this liquid,
Yes,
yellow
sir.
liquid into
It
the
will raise,
pink
sir.
liquid.
Sir, it will raise, sir.
So what is the height raise?
I bite.
So 5/2.
Uh,
5/2, sir. 2.5 centimeters.
Five by two is not the answer. That's why I asked this question.
Yes, no, sir. What is the answer, sir?
That you have to find out.
5/2 is not the answer, you said, sir.
Yes. Let me decorate it a little bit. By that time, you do it properly yourself.
Sir, 5/3.
I was knowing what was the expected answer, and you said 5/2. That was wrong. 5/3 is also wrong, actually. No, wait, 5/3. Wait, that I don't. Wait, let me check once. Is it correct or not? Let me check.
I think 5/3.
Okay, let me tell you. Let me tell you what is the mistake that you are committing. You are assuming as if when we fill it up, then this end also lowers down by h.
Yes.
You are not considering that into account. And one more thing, I forgot to mention, but you should have asked me that is it of same area or not. But if I don't mention, then yes, it is wise to assume area to be same, because if areas are different, then volume coming down will be equal to volume going up. Let us say this area is 2a, or this area is, let us say, a/2. If this area is a/2, then this height will be 2h, because a/2 into 2h will be equal to a into h.
Yes, sir.
Understood?
Yes, sir.
So volume going down will be equal to volume coming up.
Yes,
So,
sir.
but here let us assume area to be same. Then height will be same, going down and going up. If it is going down by h height down, then what will be the situation afterwards? Situation afterwards will be this left limb yellow liquid height will be not 5, it will be 5 plus h.
5 plus
And the
h.
other side it will be not bh, it will be 2h. Other side it will be 2h. Okay, then what will be the situation? Then we will be getting it as
5/3.
rho into g into 5 plus h. Rho into g into 5 plus h, p naught plus this. That will be pressure here, p. And at the same level, at the same horizontal level, within the same liquid, at the same horizontal level, within the same liquid, pressure will be same. At same horizontal or apparent horizontal level. Depends. If it is not accelerating, then horizontal. If accelerating, then apparent horizontal level. At the same horizontal level, within same connecting liquid, connected liquid. Connected means it should be same liquid also, both sides. No, it is not. At the same horizontal level within the same connected liquid, it is directly connected from here to here, right? Then only we are able to do that. Within the same connected liquid, pressure will be same. So if here it is P, then right side I don't have to find out. Directly I can say quickly that it is P only. If you don't want to do directly, then you have to first take unnecessarily Y, then you have to again decrease by Y. So you can first increase by Y, rho g Y. You can first increase by rho g Y, then you can decrease by rho g Y. But what is the use of doing all that when it is finally cancelling each other? So finally we can just take P and here also P directly. Then we are writing P naught plus C. Here I am writing in this place. In this place it is P naught plus rho into G into 5 plus H. After that liquid lowers down by height H.
Yes, sir.
And right side
2 rho
P
g
naught
into
plus
2h,
rho
sir.
into 2 rho.
2 rho, sir. 2 rho into
G
2h.
into 2H.
2h. We get h equal to 5/3, sir.
P naught plus 2
5/3
rho into G into 2H. P naught cancelled. Rho G cancelled. 5 plus H is equal to 4H.
H equal to
So 5 by, somebody said 5/3, I think.
Yes, sir.
That was right. That you said right. So it is 5/3, not 5/2. Again, sometimes I may ask this question also. That this liquid is filled on the top of it, but not up to the brim. Here I am saying up to the brim. Up to the top. Brim means up to the
So it will be less
top.
than 5 then.
If I don't say it is filled up to the top, and if I simply say that it is filled up 5 column height, 5 centimeter height, it is filled. I'm not saying it is filled up to the top. I'm just saying it is filled 5 centimeters height column. Then I think your last answer maybe will be correct. I think so. 5, yes. Then it will go down 5/2. It will rise 5/. No, then also your answer will be wrong.
Then also same only, sir.
Then also answer will be wrong. I think so. If I say it is filled by up to 5 height only, what I'm saying this
5/4
time,
we will get, I think so, sir.
then we will be getting 5/4. I think, huh?
Yes,
5/4 we will
Sir,
get.
5/4.
So 5/2 was not correct even in that case. How we get 5/4? Let me tell you what is happening now.
5/4, sir.
5/4 only. No, I know that you know, but some all students may not be knowing. No, I am considering that those also. So let me explain a little bit. This is one question that I am filling it up to 5 column height, 5 centimeters height, not up to the top, just 5 centimeters height. I will fill up. That is enough. Then this will be initially level was here. From here it went h down and it went h up. Sorry, what I'm saying. This went h up, but this side went h down. Then the height difference will be 2h, and this is 2 rho. So I can say 2 rho into g into 2h, and on the other side it is rho into g into 5. Then I'm getting directly h is equal to
5/4.
5/4. That is the other case in which I don't fill up to the brim, but I fill up to just 5 centimeter column height. Then also answer will not be 5/2. Then answer will be 5/4. But if I ask you, what is the level difference between these two? I'm not asking, let us say, what height it will raise, but I'm asking what is the level difference. Then answer you gave that 5/2. So that answer is only for those questions when I don't ask you how much height it is raising or how much height one side is lowering, but I'm asking you just what is the height difference. Then height difference is 5/2. Okay.
Yes, sir.
That too for this case, not for the other case when it is filled up to the top, not for that case. Because if it is filled up to the top, then the total height will become not 5 but 5 plus h. Okay.
Sir, once explain, sir, that part.
Sir, I
Which
can't understand
five
the difference between both
How,
questions.
how 5, sir?
why will it not be 5 plus h really? Are you thinking that it will be just filling it up to the top and then it will not lower down? If it go when we start pouring it up, then this level will also come down, and as it comes down, then it will become 5 plus h total. The liquid will not just stay here only rigidly. It will also move down or not.
Okay,
Upper
sir.
liquid yellow will push the pink down. If yellow pushes the pink down, then yellow will make a more space for itself or not.
Yes, sir.
Then the
Another
space will
day,
not be
also.
just.
Thank you,
Then
sir.
the space will become 5 plus h. Okay.
Sir,
Okay,
but
sir.
in the down now recently you said no, sir. Below case.
Mm-hmm.
There, why didn't it move down, sir, more?
Sir, here you take.
This question was
Yes,
that
sir.
I'm filling. Question is I'm filling 5 centimeter column height,
Okay, with compression.
not with compression. What is this boy even talking about? I don't understand really. Oh my God. There is liquid is not getting compressed. Liquid is not getting compressed.
Okay, sir.
It is just coming down from here. As it is coming down from here, from other side it is rising up. Where is it getting compressed? The volume it is going down in left hand side. Same volume it is rising up on the other side.
Yes,
Liquid
sir.
is incompressible. I told you the definition of liquid, that liquid will be incompressible and gas will be compressible.
Yes, sir.
So it is not shrinking. It is not like getting compressed. So it is decreasing in height. Why don't you understand the practical scenario? If it goes down, it will be rising up. Or will it just go down and it will not rise up? What do you think? What is coming in your mind? I don't understand really. You are thinking I will pour it down and it will come down and it will not rise up. Then what is this question all about? It will rise up or not
Yes,
as it
sir.
goes down.
Raises, sir.
This
Only
So if
one I
it goes
understand.
down, what will be the space now? Will the space remain still 5 centimeter height only, or will it become 5 plus h height?
5 plus h, sir.
Thus, yes, so the space for the yellow liquid will become more as it goes down. It will make more space for itself. And second question was different. Here, statement of question is different. I'm not saying that it is filled up to the top. I'm not saying it is filled up to the top. In this
Okay,
case,
sir.
this is also h height. This is going down by h height. Here also it remains h height extra then. I'm not
Oh.
saying it is filled up to the top.
Okay, sir.
I'm just saying that it is filled 5 centimeter height. But I'm not saying it is filled up to the top.
Understood, sir.
Okay.
Okay, sir.
Right. So fine. Now, Similar question I can ask with 3 liquids or 4 liquids. Always the situation will remain same only anyway. How many numbers I may give. Lighter liquid, densest. What will be the pressure at the depth at the bottom of the container? What will be the pressure at the bottom of the container? Tell me.
So that
If it is given
Heights we need.
y1, y2, y3. It will be just P naught
P naught
plus
plus
rho 1
Rho 1
G
y1
into
y1
rho 1
plus
y1
rho
plus
2
Rho
gy2.
1
Yes,
y2
sir.
plus rho 3 y3 gy3
gy3 plus rho 4
plus
gy4.
rho 4 gy4.
Yes, like that it will be.
Yes,
Can
sir.
you answer such questions if I ask you for?
Sir.
If I give you such cases for YouTube, can you still get the answers for those?
Yes, sir.
We tried, sir.
Find out what is the relation between the densities. Find out the relation between the densities. Make the KVL in the KVL means it is not KVL, but it is equivalent to KVL. The sum of pressure differences in a closed loop will be 0. Use always that. You will always get the answer.
Rho 1 H1 plus rho 2 H2 equals to rho 4 H4.
Yes, sir. That will is.
P naught plus rho 1 h2 plus rho 2 h2 plus minus rho 3
Sir, rho 1 plus rho 2
h3.
plus rho 3 is equal to rho 4.
Sir,
Rho 1 H1 plus rho 2
Rho 1
H2
h1
plus rho
plus
3
rho 2
H3
h3
equal to rho
rho
4
4
H4,
H.
sir.
rho 4
Yes,
h.
sir. Yes.
Rho 3 H3 won't be there, sir.
Rho 1 H1 plus rho 2 H2 is equal to
Rho 4 H.
rho 4 H4. Are you
Rho
getting
4
that?
Yes, sir.
Right. Correct only.
Yes, sir. Rho 3 both sides positive negative get cancelled.
Yes, sir.
Yes.
Find out the angle theta in terms of rho 1 and rho 2. Are you understanding the situation?
yes, sir.
This one line is vertical. With vertical, what angle the interface makes? what angle does the interface make with the vertical, that we have to find. Each of these is occupying 90 degrees part, means quarter circle part.
Quarter circles.
Total is a semicircle of these two liquids. Each liquid is a quarter circle, and we have to find out
Yes.
what is the angle made by the interface with the angular position of the what is angular position of the interface with respect to vertical. We have to find angular position theta of the interface with respect to vertical. Do that. This is a vertical circular tube. Getting answer? Use the same logic. It depends only on vertical side. You know that or not?
Yes, sir.
Yes, sir.
Let this side be. Let this side be H1. Let this side be H2. It is P naught. P naught plus rho G H2. That is the interface pressure. But that interface pressure, if I calculate from the other side, then it is P naught plus rho 1 G H1. So I'm getting rho, sorry, one side rho 1.
Rho 2G, sir.
I am getting rho 2 H2 is equal to rho 1 H1 again. So just you have to find what is H1, what is H2, and we get the answer in terms of theta. How to find H1 in terms of theta? That you apply common knowledge, common sense or logic. Let the radius be R. I hope you can do it. Don't make it two. Don't make such circle. Make a single circle. Then it will be easy to find out.
R minus R sin theta is H1.
Sir, R minus R sin theta is H1.
Sir, R minus R sin theta is equal to H.
You are getting wrong. H1 is equal to actually R
R
cos
sin theta
theta
plus cos theta.
minus
Sir.
R sin theta. That is
Yes,
H1.
sir. Sorry.
Yes, sir. Yes. We are
What
not
is H2?
considering
That
that
I don't know
last
till
one.
now.
R cos theta plus R sin
This
theta. That is.
this one will be theta, and this
R-
one will become, this little part will become r sin theta.
Yes, sir. R
And
sin
this
theta
bottom part
plus
will
R
become,
cos theta.
yes.
Consider it is touching at the bottom. So take an R.
Yes, sir.
instead of
They
R
didn't
cos.
consider that last part.
That's why I said, don't consider in this. In this, there may be difficulty to understand. Therefore, I turned it into a single circle so that at least we can see this properly. But then also you committed mistake. So please be careful next time. Don't commit this. So R cancelled. We are no rho 2 H2. Rho 2 H2 means rho 2 into H. Sorry,
R cos theta plus
rho
R
2
sin.
into
R cos
R
theta
sin theta plus
plus
cos theta is equal to
Equals
rho 1
to
into R
into R
RR
into cos
cancels.
theta minus sin theta.
cos theta minus sin theta. Then R cancelled. We are getting rho 1 by rho 2 equal to,
Tan 45 minus
Sir,
theta.
yes, sir. 1 minus tan theta by
I
1
think
plus tan.
you are right.
Yes, sir.
Sorry, cos. Divide by cos theta both sides. We get 1
And
plus
tan
tan theta. Divide
45
by
plus
cos
tan theta, sir.
1 minus tan theta.
Tan pi by
That
4
is equal
plus
to
theta.
tan of pi by 4 plus
Theta.
theta. Correct.
Yes.
That is the answer. Thank you. Then we have if I want to find horizontal forces due to fluid, how to find out? Can you find it out? What is the horizontal force on the right side wall? Or on the left side wall? Hello.
Yes,
Yes,
sir.
sir.
Can hear you, sir.
Audible, sir.
What is the horizontal force on the left side wall and the right side wall? And if base we don't need, if you want base, oh no, we don't need base for this. So I'm not giving you base length. And we need width. Width we need. Let me give you width. Width is, let us say, B along Z axis. Have you understood the situation?
Yes, sir.
First, I want you to make 2D diagram, but I think some of you may not have understood it. So I made it into 3D. So you can see that what is the force acting on this container we want to find in the right side wall or in the left side wall also. What you need for this? You need the width, B width you need. That I have given, H height I have given. It is inclined at an angle. Theta. One side wall is inclined. Means it is a container which is having one wall as oblique, inclined at an angle theta with horizontal. Oblique container. Can you get it? You attempt by that time. Let me do some work of diagrams. Make some free body diagram, you can get the answer. What is the force on the left side wall? P into dA.
DA.
And what is the force this side? From inside, it will be acting outwards, right? You understand how the force is being applied here? It will be acting perpendicularly outwards. 90-degree angle to this area. T means area along area vector, I can say.
Sir, time completed. Sir.
Okay.
Sir, tell this last one.
dA dash, different area, dA dash. So I'm first talking about left side. Left wall. On left wall, P into dA will be equal to P naught plus rho into G into Y into dA. And here comes very interesting part. I will do the integration without integration. You tell me what should I do?
Y into DA gives that.
Sir, rho naught into dA.
Sir, that rho naught into dA.
Sir, rho naught into dA. How came, sir?
What?
Rho naught into dA.
Rho naught into D. I don't. What is it? Is P naught. What is rho naught here?
Yes, sir.
Pressure
P
P
naught
naught.
into
Sir, in the
dA.
first step you did bracket.
P naught plus rho G Y into D it is.
Okay, sir. Understood, sir.
Why would it be just P naught plus rho G Y into dA? Total pressure, no? Total pressure at a depth P. At a depth this place, what is the pressure P? P pressure at a depth Y. At depth
Is non-direction.
Y.
It is same. So that I have written.
Pressure P is equal to already P naught plus rho G Y. That is the pressure at a depth y.
In vertical direction. That is.
This only I'm using here. Okay. We are discussing only for left wall for the timing.
Sir, P naught plus rho g y is pressure in vertical direction, sir, on that element.
Again, see what is Pascal's law?
Yes, sir. I was saying in all directions it will be same, so we are equating that.
So yes, in horizontal also it will be same. That is what the Pascal law states.
Yes.
If it is again you are saying this statement itself becomes wrong. This statement itself becomes wrong. That pressure in vertical direction is this and in horizontal it is. This we used to think at that time when Pascal law was not there. Now Pascal law is there, so we shouldn't even use that word. That it is in which direction. That thing itself is wrong. I should not even write px or py. That I wrote just once, but we will not do it again anytime. Because Pascal law has already clarified it, that it has to be same in all directions. So I will just call it P. That's why it is just a scalar. Otherwise, probably it would be acting like a vector, which will have some components Px, Py, and Pz. Okay.
Okay, sir.
So what we get now? This then. Why I'm writing y into dA? You understand this part or not? This statement, this thing is very important here because
Yes,
it
in
is saving
center
us
of
from
mass we have done it.
Yes,
Center
sir.
mass formula.
in center mass we have done this. You remember?
Yes, sir. Remember.
Yes, sir.
Then center mass of what? Center mass of what? Is it center mass of liquid?
Center mass of
Or
No,
is it
sir.
center mass
That
of anything?
No, sir.
area.
Area,
of
sir.
that
It
plane.
is center of area.
Yes, sir.
It
Only
is
about
y
that
means
area.
here it is center of area actually. It is center of area means it is center of which area? It is center of
Up to H only.
this.
Left.
It is center of this area.
Yes, sir. Left to wall.
H by 2. It will be H by 2. It is center of left wall area.
Yes, sir.
It is center of left wall area, and that is
H by 2. Okay.
H by 2. So what we get then? We are getting simply answer as P plus G.
It is getting break.
Sir, your voice was breaking, sir.
I'm not saying anything. How is it breaking?
It is clear, sir.
Now it's clear, sir. Okay. Before only one state had it.
Yep, completed.
Yes, sir.
Yes, sir. Okay, sir. Time is
Okay, then
also.
let us end it here. Tomorrow we will start again from here. Today I was discussing horizontal force. Tomorrow I will discuss horizontal again as well as vertical also.
Yes, sir.
And
Sir,
this is
today's
because you are
work.
not wait a second. Work is just keep on revising what I'm telling. Other than that, Ramachandra is giving you some notes or not? Some
Morning problems. I guess.
assignment is given by Ramachandra or not?
Yes, sir. Mornings
Yes,
are
sir,
at
morning.
center. Daily assignment.
That you do.